Hello. On this module we are going to see different environments for the software radio defined systems. The first question is, what is GNU Radio and why do we want it? GNU Radio is a radio environment for software defined radio. This environment is based on mainly in Linux operative system, and GNU is a radio, it's an open source software development toolkit that provides signal processing blocks to implement software radios. These blocks are different blocks used in communication, like amplifiers, modulators, demodulators, whatever. These modules are included in GNU Radio, and it can be used with any RF hardware connected to the system. And we can create software-defined radios with these blocks. GNU is widely used in hobbies, academic and commercial environments, and they have a support page, gnuradio.org. What does GNU Radio do? GNU Radio makes all the signal processing. It has all the blocks we can need to build a radio system. It only handles digital data, so it takes the data of the RTL dongle and it handles the I and Q data to make all the processing. That it allows you to connect different blocks without taking care of the data types, complex, real or whatever. GNU is primarily written using Python and C++. Python is used for most blocks, and C++ is used for performance critical signal processing. So it's very high and very fast and very efficient. Thus the developer is able to implement real-time systems and rapid applications without knowing anything about Python or C++. Do I need to program GNU Radio to use GNU? Well, of course, it's very interesting to be able to program on Python or C++. But in the first stage, you don't need it. You can do a lot of things without doing programming. If you want to become an advanced user, you can write these modules and you can distribute in the community of GNU, and you can get the modules of other people and modify the code of these modules. So it's very useful, but you don't need it in the first stage of working. This is an example of GNU program. We can see there are only blocks, and each block has their own parameters. We can click inside these blocks and modify the parameters, and then we connect different types of blocks, and they have different types of input and output data, real data, complex data, different types. Here we can see some message when we execute the program, and it's all running in Linux. So this is mainly for the Linux users. This is an example of the output of a GNU. The graphical interface is powerful, so we can obtain fast graphics like this, frequency spectrum, or this one, or this type of histogram, and we can use a lot of controls very easily. Python is the programming language used to build GNU. Python is a high-level general purpose dynamic programming language. It's similar to C++, but the structure is shorter, and Python code can be packaged also into standalone executable programs, and it's free and open source software. So as I said before, it's very interesting to be able to write Python code if you want to progress in the GNU environment. Then for Windows user, there are also Labview. Labview is a software developed by National Instrument in 1996, and it's widely used in the industry. And in the last year, National Instrument has been pushing very hard in the software-defined radio technology, and they have integrated a lot of their own software radio-defined device, and they have now a complete development environment similar to GNU and to MATLAB Simulink. Although in some ways communication engineers prefer the environment of GNU and Simulink because it's more familiar to the things we do with analog blocks and these things. But on the other hand, Labview is very powerful and has a support. So if you make a code on Labview now, you know this code will be available during, and you can execute it during different versions of Labview during the next 10 years or more. Labview operation, they have 3 blocks: design, control, and measurements. They can cover all the engineering, electrical engineering works, signal and image processing, industrial control, FPGAs, robotics, everything. So if you are able to handle Labview, you can control and make many different things. The software-defined radio environment of National Instrument is based on their own device, software-defined radio device, and the Labview environment. It's a medium power solution, more powerful than the RTL and more expensive also. It's based on this ETUS technology. This box has a receiver and a transmitter, and it has a wide frequency bandwidth. There are different models, and it can handle 30 to 60 MHz bandwidth, so it's more powerful on these ways than the RTL dongle. It is also much more expensive. This is an example of Labview. As we can see, it's similar to GNU and of course similar to Simulink, but the configuration is a little different, and there are many of low-level blocks and conversions. So you see the types of data, the different colors of the lines. So it has some special things that has a short time to learn this technology. And this is the output of a radio software example, where we can see the spectrum of a signal and the time of a signal, and here is the configuration. It's very similar to Simulink environment and to GNU, as we can see. The graphical interface, the output is very similar, and we can change these modules and this parameter easily. So this is the two different environments. We have Simulink, GNU, and Labview. From these 3, all them make similar things and work on different hardware device. That's it. Thank you for your attention. You can follow us on Twitter or Google.